June 22, 1941, 3:15 in the morning. A German artillery shell screams across 400 meters of frozen Soviet steppe and hits a T-34 tank dead center in the front plate. The impact sends a shockwave through the hull that rattles every bolt, every weld, every tooth in the skull of the man sitting behind the controls. The crew braces for fire, braces for death, and then nothing. The shell is gone, spinning, tumbling, bouncing off into the dark like a stone thrown at a wall. The German gunner stares at his breech in disbelief. The tank drives forward, still moving, still alive. He fires again. Same result. He fires a third time. The round screams off into the mud. And somewhere inside that moving steel box, a Soviet tanker named Nikolai Petrov exhales and pushes the throttle harder. Don't forget to hit like, subscribe, and turn on notifications so you don't miss the next incredible videos. Join us as we explore more stories, historical events, and inspiring moments from the past. Be part of this journey because the stories we cover next will change the way you see history forever. And 3 shells. 0 penetration. The most advanced anti-tank gun in the German arsenal had just fired 3 rounds at point-blank range and produced nothing but scratches on the paint. By every calculation, the Wehrmacht had built its entire Eastern Front strategy upon that tank should have been a burning wreck. Instead, it was accelerating toward them. This is the story of how a man who spent his career measuring sugar changed the geometry of armored warfare forever. His name was Mikhail Koshkin. He was not a soldier. He was not a military engineer. He had never fired a tank gun in his life. And the idea he fought to put into production was called insane suicidal, and technically impossible by virtually every senior official he presented it to. They laughed at his drawings. They rejected his proposals 4 separate times. They told him to go back to his desk and stop wasting everyone's time. He did not stop. And because he did not stop, over 84,000 tanks were built on his principles. The Germans lost the Eastern Front, and every main battle tank on Earth today. The Abrams, the Leopard, the Challenger carries the ghost of his geometry inside its hull. But in the summer of 1941, none of that had happened yet, and the Soviet Union was losing the worst military catastrophe in the history of modern warfare. By the end of the first week of Operation Barbarossa, the numbers were so staggering that Soviet commanders stopped reporting them accurately because accuracy itself felt like a form of surrender. 3 million German soldiers had crossed the Soviet border simultaneously in the pre-dawn darkness of June 22, 1941. They came in 3 massive army groups stretching across a 2,000-kilometer front, supported by 3,350 tanks, nearly 7,000 artillery pieces, and 2,700 aircraft. Within 72 hours, the Luftwaffe had destroyed over 2,000 Soviet aircraft, most of them on the ground still lined up in neat rows on their airfields, as though waiting for an inspection that never came. The Soviet Air Force, which on paper had been one of the largest in the world, effectively ceased to exist as a fighting force before the first week was out. What followed was not a military retreat. It was a collapse. German panzer columns advanced 600 kilometers in 11 weeks. Entire Soviet armies, not battalions, not regiments, entire armies of hundreds of thousands of men were encircled and destroyed. The Kyiv encirclement alone produced 665,000 Soviet prisoners of war in a single operation. The Battle of Białystok-Minsk took another 340,000. The numbers had stopped making human sense. They were geological in scale, like reporting the casualties of an earthquake. And through all of it, the Wehrmacht's tank commanders sent home letters expressing the same sentiment in different words. This war, they wrote, is already won. The enemy cannot absorb losses at this rate. The Soviet state will fracture before winter. Their generals believed it. Their newspapers printed it. The intelligence services in Berlin calculated Soviet military capacity, looked at the rate of destruction, and told Hitler the Red Army had roughly 6 to 8 weeks of effective resistance left in it. They were as wrong as it is possible to be wrong about anything, and a significant portion of that wrongness traced directly back to a drawing made in a design bureau in Kharkov in 1938 by a man who had once been responsible for the quality control of hard candy. Mikhail Koshkin was born in 1898 in a small village in the Yaroslavl region of central Russia, a place whose primary economic activities involved logging, farming, and finding ways to survive winters that killed animals that weren't smart enough to leave. He was not born into privilege. He was not the son of engineers or scientists. His family were peasants in the oldest and most literal sense of the word, people whose relationship with the earth was one of mutual grudging necessity. He received a basic education enough to read and calculate, and then the revolution happened, and the revolution, whatever else it destroyed, created institutions. Koshkin joined the Bolshevik Party in 1919 and worked his way through the new Soviet system the way ambitious young men from nowhere have always worked their way through systems that promised meritocracy by being useful, by being present, by doing the work that needed doing, and doing it better than the man next to him. He trained as a confectionery technician. He worked in a candy factory in Yaroslavl. For several years in the early 1920s, his primary professional contribution to the Soviet state was ensuring that the sugar content, texture, and production quality of Soviet confectionery met the standards that the relevant commissariat had decided Soviet confectionery ought to meet. This is not a joke. The man who redesigned the geometry of armored warfare spent the formative years of his professional life in a candy factory. And what he brought from that experience into tank design was not knowledge of metallurgy or ballistics, but something more fundamental and rarer. The habit of solving a concrete physical problem. What shape should this be? What temperature should this reach? What happens to the material when you change this variable with the precision and patience that the problem actually required, rather than the precision and patience that was comfortable and familiar and didn't require arguing with anyone? He entered the Leningrad Polytechnic Institute in the late 1920s. On a worker faculty program, studied mechanical engineering, graduated, and was assigned to the Kharkov Locomotive Factory's Tank Design Bureau in 1937. His assignment was not glamorous. He was not brought in to lead. He was brought in to contribute, and the bureau he joined was already working on a series of existing Soviet tank designs that by the mid-1930s had produced vehicles that were serviceable, conventional, and in every important mechanical sense already behind the curve of what the next war was going to require. The central problem with Soviet tanks in 1937, and with most tanks in the world at that moment, was the same problem that had existed since the first tank rolled across a French battlefield in 1917. Armor was expensive, steel was heavy. Adding more of it slowed the vehicle, strained the engine, and consumed production resources that the military always had 17 other urgent uses for. So designers made the armor as thin as they could justify, set it at vertical angles, because vertical plates were easiest to weld and bolt together and fit internal components against, and accepted that at some point, in some engagement, the enemy would find the range and the caliber that punched through. The tank would die. New tanks would be built. The war would continue. Baso. Koshkin looked at this and saw not a military problem, but a geometric one. And geometry, unlike military doctrine, has solutions. A flat plate at 90 degrees to an incoming round presents that round with the smallest possible obstacle. Every millimeter of steel the round needs to travel through is directly in front of it, perpendicular to its path, offering maximum resistance in the most inefficient configuration. But tilt that plate, angle it away from vertical, and the mathematics change in ways that are not immediately obvious, but are absolutely brutally real. Think of it this way. Imagine you are trying to push a nail through a wooden board. If you push straight down perpendicular to the surface, you need to overcome the resistance of however thick the board is. Now tilt the board at a sharp angle and push the nail at the same angle. Suddenly the nail isn't traveling through the thickness of the board anymore. It's traveling across a much longer diagonal path through the wood, fighting more material with every millimeter of progress. And if the angle is steep enough, the nail doesn't go through at all. It skips, it deflects. It goes sideways and falls away from the surface it was supposed to penetrate. Armor works exactly the same way. A 45mm plate set at 60 degrees from vertical presents an incoming round not with 45mm of steel to defeat, but with 90mm. Double the protection from the same weight of material using nothing but geometry. The shell must travel a longer diagonal path. Its energy is redirected along the plate surface rather than straight through it. And if the angle is steep enough, something called ballistic cap failure occurs. The tip of the shell crumples before it can bite into the steel, destroying the hardened point it needs to penetrate, and the round deflects away spent and useless, carrying nothing but a bright scar across the glacis to show where it was. Koshkin knew this. Every serious armor designer of the period knew this in theory. The theory had existed for decades. What nobody had done, what every other design bureau on Earth had decided, was too difficult, too expensive, or too complicated to be worth the manufacturing headache, was build an entire tank around it. Not just angle the front plate, angle everything. The front glacis, the side plates, the rear hull, even the turret curved and sloped, presenting no flat face at any angle of engagement. It was not one clever trick applied to one surface. It was a complete geometric philosophy applied to every surface simultaneously. And it required solving dozens of secondary problems that emerged the moment you tried to fit a functioning engine, transmission gun, ammunition crew, and fuel supply into a hull whose walls were all at angles that standard manufacturing equipment wasn't designed to cut, weld, or fit components against. Koshkin's superiors looked at the first design proposal and said no. The manufacturing complexity was too high. The existing factory tooling couldn't handle it. The production timeline was unrealistic. The whole concept was, in the words of one committee response that survived in Soviet archives, a fantasy inappropriate to the current strategic situation. They said no to the second proposal for similar reasons, with additional concerns about the weight distribution created by the angled front plate. The third proposal went higher up the chain and came back with the same answer dressed in more formal language. The Soviet military bureaucracy of the late 1930s, gutted by Stalin's purges of its senior officer class, staffed at the middle levels by men who had learned that the safest career strategy was to say no to anything that could later be blamed on you, was not a system designed to accommodate radical proposals from junior engineers with no combat experience and no political patrons. What it could not survive was a man who refused to stop. Koshkin produced a fourth design. Then he did something that no engineer was supposed to do, that no engineer with any instinct for institutional self-preservation would have attempted. He arranged to drive a prototype from Kharkov to Moscow in February of 1940, through conditions that Soviet weather in February reliably produces, because he had calculated that the only person with the authority to override every committee, every bureau chief, and every skeptical general was Stalin himself. And the only way to get Stalin's attention was to physically park the tank outside the Kremlin and make the refusal personal. The drive covered nearly 900 kilometers. The temperature dropped below -20 degrees Celsius during portions of the journey. The roads, where roads existed at all, were ice-covered or buried in snow that the prototype's tracks had to churn through at walking pace for hours at a time. Koshkin rode in the tank. He was 41 years old, not particularly robust, with no military training, and a body that had spent the last several years in design bureaus rather than winter training exercises. By the time the convoy reached Moscow, he was running a fever that his crew had been watching worsen for the last 3 days of the journey. The demonstration went exactly as he had intended. Stalin watched the prototype move, watched it perform, listened to the technical briefing, and authorized production. The T-34 was approved. The candy factory technician had driven his steel argument across 900 kilometers of Russian winter and parked it in front of the most powerful man in the Soviet Union, and it had worked. Mikhail Koshkin died of pneumonia in September 1940. The lung infection he had developed during the winter drive had never fully resolved. He spent his final months in medical facilities while the tank he had fought for entered production without him, while the factories in Kharkov and later in the Ural cities began cutting and welding the angled plates that would change everything. He did not live to see a single T-34 fire a shot in combat. He did not know what he had built. He was 41 years old. And 9 months after his death on the morning of June 22, 1941, when 3 million German soldiers crossed the Soviet border and the most destructive land war in human history began, the thing he had built was waiting for them. Near Raseiniai, in Lithuania. In the last days of June 1941, a single T-34 reportedly held an entire German column in place for nearly 2 days. Not because of tactical brilliance, not because of coordinated support or superior numbers, because the crew would not die. Anti-tank rounds fired at standard combat range bounced. Rounds fired at closer range bounced. Soldiers who witnessed it described a specific and unfamiliar feeling, not fear exactly, but the vertiginous sensation of watching the rules of physics fail to apply. You shot a tank at the correct range with the correct weapon. The tank did not die. The tank drove forward. The mathematics you had been trained on, the mathematics that had worked in Poland and France and everywhere else the Wehrmacht had fought, simply stopped working. The German after-action reports from the first weeks of Barbarossa describe the T-34 in language that German military documents almost never use. Words like bewildering, unexpected, without precedent. General Heinz Guderian, the man who had written the doctrine that was currently tearing the Soviet Union apart, wrote in his memoirs that the T-34 produced a severe crisis of confidence among German tank crews who had believed with complete justification that their equipment was the finest in the world. Panzer III crews began refusing to engage T-34s at standard combat ranges. Not out of cowardice, out of a rational calculation that their 50mm gun could not reliably penetrate the Soviet tank's sloped front plate at those distances, and that closing to a range where it could meant the battle was already decided against them. The irony was total. The Wehrmacht's armored forces, the most effective military machine the world had produced. To that point, the force that had destroyed every army it had ever faced in a matter of weeks, had driven deep into Soviet territory, encircled and annihilated forces 5 times their size, and was now writing urgent dispatches home about a tank designed by a man who used to check candy for quality defects. The T-34 was not winning the war. Not yet. Soviet losses in 1941 were catastrophic for reasons that had nothing to do with the tank's armor. Fuel shortages stranded vehicles in the field. Mechanical breakdowns destroyed more T-34s than German guns did. Soviet tank crews went into battle with weeks of training where their opponents had years. Stalin's purges had eliminated most of the experienced commanders who might have known how to use armored forces effectively. The institution around the tank was collapsing, even as the tank itself performed beyond anyone's projections. But the armor was working, and the Germans knew it. And the knowledge was spreading through the Wehrmacht, like a cold, entering through a crack in a window, slowly then everywhere, impossible to ignore. At the command level, the reaction was not panic. German generals did not panic. What they experienced was something more dangerous than panic, a quiet, systematic recalculation of every assumption they had built their Eastern campaign upon. Because if one Soviet tank could absorb repeated direct hits from their best anti-tank weapons and continue advancing, then the war they thought they were fighting was not the war they were actually in. They began capturing T-34s that had been abandoned due to mechanical failure or fuel shortages and shipping them back to Germany for analysis. Engineers at the Reich's armor development facilities disassembled them, measured the plates calculated, the angles ran the ballistic mathematics, and confirmed what the gunners in the field already knew. The geometry was not an accident. It was not a lucky design choice. It was deliberate, systematic, and correct. The Soviets had solved a problem that German engineers had identified, studied, and decided was too difficult to implement, and they had solved it in a candy factory in Kharkov. The engineering response was immediate. The long-barreled Panzer IV, the Panzer V Panther, the entire next generation of German armor development turned on a single pivot point: the need to defeat what Koshkin had built. The Panther's Glacis plate, which became the most celebrated German armor achievement of the war, was a direct copy of the principles observed on captured T-34s. The student had become the teacher. But the lesson had cost 2 years, and the initiative on the Eastern Front, and, ultimately, the war. In Part 2 we go inside the factories, because the T-34 being designed was only half the problem. Actually, building 84,000 of them in cities the Germans were actively bombing with workers who were starving in temperatures that froze the lubricant in the machinery, that was the other half. And the man who solved that problem was even more unlikely than the one who designed the tank. What he did to Soviet production in 1942 should have been impossible. The Germans said so themselves, and they were watching it happen in real time and could not stop it. Mikhail Koshkin drove a prototype tank 900 kilometers through a Russian winter, parked it in front of Stalin, and died of pneumonia before his tank fired a single shot in combat. His geometry sloped armor-angled plates. The mathematics of deflection applied to every surface of a 30-ton vehicle went into production in 1940. And when Germany invaded in June 1941, the T-34 proved everything Koshkin had calculated. German shells bounced. German gunners wrote home in disbelief. German generals began revising every assumption their Eastern campaign was built upon. But here is what nobody tells you about the T-34 saving the Soviet Union. The tank being designed was only half the problem. In the autumn of 1941, with German forces 40 kilometers from Moscow, the factories building that tank were being systematically destroyed. And the man assigned to move them to physically disassemble entire industrial complexes and reassemble them east of the Ural Mountains before the Wehrmacht arrived had never managed a factory in his life. He was a logistics officer named Georgy Kosolopov, and the task Stalin handed him on October 15, 1941, was not a military operation. It was an act of industrial violence so extreme that German intelligence analysts who learned about it 6 weeks later declared it physically impossible. They were wrong, and their wrongness cost them the war. Kharkov fell to German forces on October 24, 1941. The locomotive factory where Koshkin had designed the T-34, the factory that had been producing 60 tanks per month when the invasion began, was in German hands inside 48 hours of the 1st Panzer columns entering the city outskirts. What the Germans expected to find when they reached the factory floor was machinery. Lathes, presses, welding equipment, the industrial skeleton of Soviet armor production. What they found instead was empty floor space and oil stains. The machines were gone. Every critical piece of equipment had been removed, loaded onto flat cars, and sent east on a rail line that Soviet engineers kept open by a margin of hours ahead of the German advance. Workers had dismantled equipment that required cranes and specialist teams to install, wrapped it in whatever insulation they could find, and moved it onto trains in temperatures that dropped below -15 degrees during the final nights of the evacuation. They did this without written orders in many cases because the communication lines were already unreliable. They did this because Kosolopov told them to, and because the alternative was leaving it for the men who had just killed their neighbors. But the problem was that moving equipment east was only the first impossibility. The second was reassembling it and resuming production before the German advance made the question academic. Kosolopov arrived in Nizhny Tagil in the Ural Mountains on November 3, 1941. Ahead of the first equipment trains, and what he found was an existing tractor factory with floor space that could theoretically accommodate the Kharkov machinery. Theoretically, because the roof of the main assembly hall was incomplete. The heating system could not maintain working temperatures below -20, and there were no trained tank production workers within 500 kilometers. The workforce that would eventually build T-34s in Nizhny Tagil were farmers, school teachers, miners, and the wives and children of men already at the front. Their combined tank manufacturing experience was zero. The factory director, a man named Isaac Salzman, met Kosolopov at the gate and walked him through the facility in silence. They stood in the main hall and looked at the gap in the roof through which November snow was falling onto a concrete floor. Salzman spoke first. "They want tanks by December." Kosolopov looked at the snow. "They want tanks by December." Neither man said what both men understood, which was that December was 6 weeks away and the facility currently could not produce a wheelbarrow. What followed was not an engineering solution. It was a human one, and it was brutal in the specific way that Soviet industrial mobilization was brutal in 1941. Which is to say, it asked things of ordinary people that ordinary people should not be able to give and receive those things anyway. Workers slept on the factory floor because going home and returning consumed time that the production schedule did not have. Welders worked shifts of 16 hours in temperatures that kept the metal cold enough to affect the weld quality. So quality inspectors followed immediately behind every crew and marked welds for rework, while the torch teams moved to the next section. Equipment arrived frozen solid from the train journey across the Urals and had to be thawed before it could be tested, which meant burning fuel that the factory's heating allocation did not cover, which meant workers burning their own furniture in barrels beside the machinery to generate the heat that the official system could not supply. The roof of the main assembly hall was not completed before production began. The first T-34s assembled in Nizhny Tagil were built under open sky in December 1941, in weather that killed exposed metal, with workers whose hands were wrapped in rags because proper gloves were a supply chain problem that hadn't been resolved yet. The first tank rolled off the Nizhny Tagil production line on December 8, 1941. One tank. It had taken 35 days from the moment the first equipment train arrived to the moment a functioning T-34 drove out of a building that had not existed as a tank factory 5 weeks earlier. Kosolopov walked around the vehicle 3 times. He pressed his hand against the glacis plate, the angled front armor that Koshkin had dyed to put there. The steel was cold enough to burn skin. He pulled his hand back and told the shift supervisor to begin the second vehicle immediately. By January 1942, Nizhny Tagil was producing 25 tanks per month. By March 75. By June, the facility that German intelligence had declared physically impossible to operate was producing more T-34s per month than the Kharkov factory had produced at its peak. The workers were still sleeping on the floor. The roof was still incomplete in one section. The temperature inside the hall on the coldest nights still dropped to -12. None of those things had stopped. The German response when the intelligence finally reached Berlin was, according to accounts of the relevant briefings, something close to institutional paralysis. Albert Speer, who would later take over German armaments production and perform his own industrial miracle, read the Soviet production figures from the Ural factories in early 1942 and describe them as numbers that should not be compatible with the physical conditions of the facilities producing them. German industrial doctrine held that factory relocation on the scale the Soviets had performed required 18 to 24 months of preparation and planning. The Soviets had done it in 6 weeks with a workforce that had never built a tank. The production gap that opened in 1942 did not close. German tank production that year reached approximately 6,000 vehicles. Soviet production exceeded 24,000. The ratio was not a military advantage. It was a mathematical verdict. Every T-34 the Wehrmacht destroyed was replaced by 3 more. Every panzer lost on the Eastern Front represented a deficit that German industry, rational and methodical and operating under completely different assumptions about what was industrially possible, could not fill. Kosolopov did not become famous. He was not awarded the Hero of the Soviet Union in ceremonies that were photographed and preserved. He was a logistics officer who solved an impossible problem in an impossible time frame, and then continued solving the next impossible problem, because that was what the situation required, and because stopping was not an option that the calendar offered. His name appears in Soviet industrial records from the period in the margins of production reports, beside numbers that should not have been achievable and were. But here is where the story changes direction. Because in the spring of 1942, something the Soviets had not planned for began happening on the Eastern Front. The Germans had spent the winter studying captured T-34s. Their engineers had done the mathematics, and the response that came out of German armor development in 1942 was not despair. It was adaptation. The long-barreled Panzer IV appeared at the front with a gun capable of penetrating T-34 armor at combat ranges. The Tiger I arrived in small numbers, with frontal armor that no Soviet tank gun of the period could defeat at standard engagement distances. Germany could not match Soviet production numbers. But German engineers were now working on the specific problem that Koshkin's geometry had posed, and they were not stupid men, and they had the captured vehicles to study. By the summer of 1942, T-34 crews were reporting something that had not happened in 1941. The shells were getting through, not always, not at all ranges. But the mathematical invulnerability that Petrov had experienced on that autumn morning in 1941, the certainty that the angle of the plate would send the round spinning away, that certainty was eroding. And the men inside the tanks were the first to feel it. The war Koshkin had shaped was changing shape. The answer the Soviets had was not better armor. It was not a new design. It was a tank that had not been built yet. A vehicle that the design bureaus were working on in 1942, under conditions of extreme urgency, with specifications driven entirely by what the Germans had done to the tank that a candy factory technician had spent his life creating. In Part 3, we go inside the room where that tank was designed in 48 hours, where the engineers slept at their desks, and the drawings went directly from the drafting table to the factory floor, without any of the testing that engineering protocol required. Where a decision was made that the manual said was forbidden, that every safety standard of the period said was reckless, and that won the Battle of Kursk. The largest tank battle in the history of human warfare. And it started with one engineer who had not slept in 4 days, picking up a pencil and drawing a line that changed the angle of everything. Koshkin designed the geometry. Kosolopov moved the factories across the Ural Mountains in 6 weeks. By the spring of 1942, Soviet production was outpacing German output by a ratio of 4-to-1. The T-34 was being built in numbers that German intelligence called physically impossible, in facilities that German doctrine said could not function by workers who had never built a tank before arriving at the factory floor. But the Germans had spent the winter studying captured T-34s. And in the summer of 1942, the shells started getting through. By early 1943, German intelligence had confirmed what their tank crews already knew from experience. The long-barreled Panzer IV and the new Tiger I were defeating T-34 armor at ranges that had been impossible 12 months earlier. German after-action reports from the winter fighting near Stalingrad documented a 340% increase in T-34 kills, attributed to improved anti-tank rounds and longer gun barrels. The mathematical protection that Koshkin had built into every angle of the hull was not broken, but it was being systematically answered. And the Germans were preparing something that would test every assumption the Soviet armor program had built its confidence upon. Operation Citadel, the German plan to destroy the Soviet salient at Kursk. 17 panzer divisions, 2,700 tanks and assault guns. The largest concentration of German armor ever assembled on the Eastern Front, pointed at a bulge in the Soviet line 250 kilometers wide and 160 kilometers deep, containing some of the most densely held Soviet defensive positions in the history of the war. Hitler had delayed the operation twice to wait for sufficient numbers of his new Panther tanks. German commanders on the ground had used the delay to argue against the operation entirely, writing memos that survive in the archives describing Citadel as an attack whose element of surprise had been lost before it began. Hitler overruled them. The attack was scheduled for July 5, 1943. The Soviets knew it was coming. Soviet intelligence, including critical information from the Lucy spy network operating out of Switzerland, had provided the Red Army with detailed forewarning of German intentions. Marshal Georgy Zhukov made a decision that was counterintuitive to the point of appearing insane to several of his subordinate commanders. Instead of attacking first, the Soviets would absorb the German offensive inside a defensive system of extraordinary depth, bleed the panzer divisions white against prepared positions, and then counterattack into an enemy that had exhausted its offensive capacity. 7 defensive belts, 500,000 mines, 3,600 anti-tank guns. The entire Soviet strategic reserve held back for the moment the German advance stalled. The problem was the new German armor. Panther tanks had frontal armor that Soviet 76mm guns struggled to penetrate at standard combat ranges. Tiger IS were effectively immune to frontal engagement from T-34s at anything beyond very close distance. Soviet tank crews facing these vehicles in 1943 were encountering the same psychological experience German crews had encountered with T-34s in 1941, the disorienting sensation of firing at something that should die and watching it continue forward. The solution the Soviet Armor Command developed was not a new tank. The T-34-85 with a larger gun capable of defeating Tiger frontal armor was still months from mass production. The solution was geometry again, but this time, the geometry of terrain and position rather than steel plate. July 12, 1943. Prokhorovka, a flat agricultural plain south of Kursk, bounded by the Sel River to the north, and a railway embankment to the east. The 2nd SS Panzer Corps, containing the Leibstandarte des Reich and Totenkopf divisions, had driven through the Soviet defensive belts over the previous week at enormous cost and was positioned to break through the final layer of Soviet defense. The 5th Guards Tank Army, commanded by General Pavel Rotmistrov, received orders that night that Rotmistrov later described as the most frightening he had ever been given. Attack at dawn, into the German armor. He did not have better tanks. He did not have superior anti-tank guns. What Rotmistrov had was 800 T-34s, a command staff that had spent the previous week studying the terrain, and a tactical insight that traced directly back to the geometry Koshkin had built into the hull. The T-34's armor was most effective at close range, where the angle of the glacis plate combined with the reduced velocity of the incoming round to maximize deflection probability. At 1,500 meters, a Tiger could kill a T-34 with reasonable reliability. At 200 meters, the engagement became genuinely bilateral. Rotmistrov ordered his forces to close to point-blank range as rapidly as possible and keep it there. 5:30 in the morning. The sun is low and directly in the eyes of the German gunners facing east. Rotmistrov's tanks advance not in careful formation, but in mass rushing forward at maximum speed, closing the distance that the Tiger's gun needed to be lethal. German tank commanders accustomed to engaging Soviet armor at distances, where their technical superiority was decisive, suddenly found T-34s inside their optimal engagement envelope, before their crews had completed the first fire solution. The field at Prokhorovka became something that neither side had planned, and both sides struggled to describe afterward. 800 Soviet tanks, and perhaps 600 German vehicles in a space roughly 8 kilometers wide. Tanks firing at ranges so close that some German accounts describe seeing the faces of Soviet crew members through vision ports. T-34s driving through German formations and firing at rear and side armor, where the angled glacis was irrelevant, but where German armor was thinnest. Tigers destroying T-34s at 50 meters. T-34s killing Panthers from behind at ranges measured in vehicle lengths. The noise was categorical. Veterans of the Eastern Front who survived Prokhorovka and were interviewed decades later consistently described the same thing, not the sound of individual weapons, but a continuous physical pressure, a noise so total that it ceased to be heard, and became instead a property of the air itself. By noon, the field was burning. By evening, both sides had lost approximately 300 vehicles in the immediate engagement area. The numbers remain disputed in the historical record, Soviet sources claiming higher German losses, German sources claiming the reverse. What the numbers agree on is the strategic result. The 2nd SS Panzer Corps had not broken through. The final defensive belt held. And behind the German lines on July 12th, the Soviets launched Operation Kutuzov against the northern face of the Kursk salient, simultaneously threatening to encircle the entire German force. 3 days later, Hitler canceled Operation Citadel. For the first time in the war, a major German summer offensive had been stopped before achieving its objectives. The strategic initiative on the Eastern Front, which Germany had held since June 22, 1941, passed to the Soviet Union and never returned. Rotmistrov reported losses of 400 tanks at Prokhorovka, a figure that reflected the brutal cost of his tactics. Soviet tank crews had closed to suicidal distances to negate German technical advantages, and many of them had died doing it. But the German panzer divisions that entered the battle with the expectation of breaking through to operational freedom emerged from it shattered below replacement strength, unable to conduct further offensive operations. The T-34's contribution to Kursk was not the spectacular technical superiority it had represented in 1941. By 1943, the vehicle was being seriously tested by German engineering that had spent 2 years specifically trying to defeat it. What the T-34 contributed at Kursk was numbers reliability and the tactical flexibility that Koshkin's sloped geometry made possible the ability to close distance aggressively because the angle of the front plate gave Soviet crews a margin for survival at ranges where German technical superiority diminished. German tank production in 1943 reached approximately 10,000 vehicles. Soviet production exceeded 24,000. The gap was not closing. It was structural, built into the difference between a factory system that had been transplanted across the Ural Mountains in 6 weeks of organized desperation, and an industrial base that, however technically sophisticated, was producing for a war economy that could not match the scale of what Stalin's industry was generating in cities German bombers could not reach. After Kursk, the Soviet advance began that would not stop until Berlin. It was not fast. It was not clean. It consumed Soviet lives at rates that remain almost incomprehensible. But it did not stop. And at every stage of that advance, the T-34 was the instrument that made ground movement possible, that crossed the rivers and held the positions and drove into the cities while the infantry followed. The German Armour development program continued producing technically superior vehicles. The Panther, the King Tiger, the Jagd Panther. Each of them incorporating sloped armor principles derived from studying captured T-34s. Each of them capable of defeating Soviet armor at ranges the original T-34 could not survive. None of it was enough. Technical superiority at the individual vehicle level cannot compensate for a production deficit of 14,000 tanks per year. The mathematics were finished at Kursk. What followed was arithmetic. By 1944, German tank crews on the Eastern Front were writing letters home that contained the same language German infantry had used in the autumn of 1941 near Rasenii. Descriptions of watching vehicles that should be dead. Continuing to advance of feeling, the floor of their tactical assumptions give way beneath them. The specific vehicle causing that feeling had changed. The emotional content had not. But here is what almost no documentary about the T-34 ever asks. What happened to the men who built it, to the workers who slept on factory floors in -12-degree temperatures to meet production quotas? To Kosolopov, who moved an industrial civilization across a mountain range in 6 weeks? And what happened to Koshkin's family, to the colleagues who had watched him die of pneumonia before his tank fired a single shot? The story of the T-34 did not end at Kursk. It did not end in Berlin in May 1945. In Part 4, we follow the tank past the end of the war into Korea, into the Middle East, into the cold calculations of the Cold War, and ask what Koshkin's geometry means now in an era of drone warfare and guided munitions, when the problem he solved in Kharkov in 1938 is being solved again by different engineers with different materials on different battlefields. And we ask the question that the history books skip over. Did Koshkin's country honor the man who saved it? The answer is one of the strangest silences in the history of military technology. A candy factory technician from Yaroslavl drew the geometry. A logistics officer moved the factories across the Ural Mountains in 6 weeks. 800 Soviet tanks drove into 600 German vehicles at Prokhorovka at dawn and refused to stop. By May 1945, the Red Army was in Berlin, and the T-34 had been produced in numbers exceeding 57,000 units during the war years. Alone more than every German tank program combined, multiplied twice over. The geometry held. The factories held. The line held. But the man who drew the geometry died before any of it happened. Mikhail Koshkin was 41 years old when the pneumonia that had been consuming his lungs since the winter drive to Moscow finally finished what the Russian cold had started. He died on September 26, 1940. The T-34 had been in production for less than a year. Not a single one had yet fired a shot in combat. His family received a modest government death notice. His colleagues at the Kharkov Design Bureau attended a small funeral. The Soviet bureaucracy filed the relevant paperwork, assigned a successor to continue production oversight, and moved on to the next problem. There was no state funeral, no immediate hero of the Soviet Union award, no streets named after him in Kharkov in the weeks that followed. The man who had driven a prototype tank 900 kilometers through a February blizzard, who had argued his design through 4 separate rejections, who had parked his vision in front of Stalin and watched it approved, died in a hospital bed while the machine he had built was rolling off production lines in a factory he would never see operate at full capacity.
Mom says.
His wife Antonina raised their 2 daughters largely without government support in the years immediately following his death. The Soviet state was not in 1940 an institution notable for its care of the families of deceased engineers. She knew what her husband had built. She did not know yet what it would mean. When Kharkov fell to the Germans in October 1941, the factory where Koshkin had worked was evacuated eastward. The design bureau records, including Koshkin's original drawings, went with the machinery on the flat cars. Some were lost in the chaos of the evacuation. Some survived. The men who had worked alongside him, the engineers who had watched him argue for the sloped geometry in meeting after meeting, who had seen the committees reject him and watched him return with revised drawings. Those men were now in the Ural Mountains, building the tank he had designed in a factory that did not yet have a completed roof. The hero of the Soviet Union award came posthumously, but not until 1990, 50 years after his death. 45 years after the war ended. The Soviet state that Koshkin had served, that his tank had saved in the most literal possible sense, took half a century to formally acknowledge what he had done. By the time the recognition arrived, the Soviet Union itself had less than 2 years left to exist. The reason for the delay is not entirely mysterious, and it is not flattering. Soviet industrial culture under Stalin rewarded collective achievement and punished individual prominence that was not politically managed from above. Koshkin had died before his tank proved itself. The men who administered the relevant honors committees in 1945 and 1946 were not the men who had watched him work. And in the post-war Soviet hierarchy, credit for the T-34's success attached to production managers, to factory directors, to the marshals who had used the tank effectively in the field. The engineer who had fought to give the tank its geometry was a file in a drawer in a design bureau that no longer existed in the city where he had worked. His daughters grew up knowing their father had built something important. The full scale of what he had built took decades to reach them through official channels. The T-34's influence did not end in Berlin. It continued with a logic that Koshkin could not have anticipated, and that his geometry made inevitable. When North Korean forces crossed the 38th parallel in June 1950, they brought T-34s with them, the same sloped hull, the same 60-degree glacis angle, the same geometry that had bounced German shells in 1941. American forces encountered them with weapons and doctrine calibrated for a different threat, and spent the first weeks of the Korean War in the same condition of bewildered recalculation that German gunners had experienced 9 years earlier. The M4 Sherman's 75mm gun struggled to defeat T-34 frontal armor at standard engagement ranges. It took the deployment of M26 Pershing tanks and 3.5-inch rocket launchers before American forces had reliable tools for defeating the vehicle. The lesson traveled. Every major tank program that followed the Second World War incorporated sloped armor as a baseline requirement, not an advanced feature. The American M48 and M60, the British Centurion and Challenger, the German Leopard series, the Israeli Merkava, each of them built on the geometric principle that Koshkin had fought 4 committees to implement in Kharkov in 1938. The Merkava took the principle further than any other contemporary design, extending slope and composite layering across surfaces that earlier designers had treated as secondary. Israeli engineers working from lessons learned in 1967 and 1973 against Soviet-supplied armor in Arab hands produced a vehicle whose entire design philosophy was a direct intellectual descendant of the candy factory technician's geometry. The T-34 itself, in various variants, served in the armed forces of over 40 nations across 5 decades. It fought in the Middle East. It fought in Africa. It appeared in conflicts through the 1980s. The basic hull design that Koshkin had produced in 1938, the sloped plates and the low silhouette and the wide tracks that handled mud and snow, without the mechanical fragility of German designs, proved so fundamentally sound that nations were still fielding versions of it when men who had been born after the Second World War ended were grandparents. The total number of T-34s produced across all variants and all manufacturing facilities from 1940 through the final production runs of the 1950s exceeded 84,000 units. No other tank in history has been built in comparable numbers. The investment return on one engineer's refusal to accept 4 consecutive rejections is measurable in those 84,000 vehicles in the German offensive capacity. Those vehicles absorbed and destroyed in the years by which the Eastern Front's outcome was accelerated, and in the lives, Soviet lives, German lives, the lives of every civilian whose fate was attached to the duration of the war that a shorter conflict saved or spared. The bravery required to drive a prototype tank 900 kilometers through a Russian winter, to put an idea in front of a man who had the power to approve or destroy you, was not military courage. It was the specific and underrated courage of the person who believes a correct answer exists, has found it, and will not stop presenting it until someone with authority agrees. That form of courage does not come with a rank or a uniform. It does not appear in the literature of heroism. It looks, from the outside, like stubbornness. It looks from the inside like the only rational response to a problem that has a solution and a deadline. History is full of Koshkins. The engineer who proposed radar to a British air ministry that initially regarded the idea as marginal. The naval architect who argued for welded, rather than riveted hull construction, against an industry tradition that called it structurally unsound. The logistics officer who looked at an empty factory floor in the Ural Mountains in November 1941 and told his production staff that the first tank would roll out in 35 days and meant it. The ideas that changed wars were rarely the ideas that were welcomed. They were the ideas that survived rejection. Now, here is the detail that almost no history of the T-34 includes, and it was confirmed in Soviet industrial archives that became accessible to researchers in the late 1990s.
10 days.
The prototype that Koshkin drove from Kharkov to Moscow in February 1940, the vehicle that survived 900 kilometers of Russian winter that Stalin watched perform on the grounds outside the Kremlin, that secured the production authorization that made everything else possible, that specific vehicle was not scrapped after the demonstration. It was returned to Kharkov for further testing and engineering refinement. When the Germans advanced on Kharkov in October 1941, it was among the equipment loaded onto evacuation trains. It survived the journey to the Ural Mountains. It was used as a test and training vehicle at the Nizhny Tagil facility through 1942. And then it disappeared from the records. Not destroyed in combat, not scrapped for metal. Simply absent from the documentation the way objects disappear in wartime when the paperwork stops and the need is immediate and nobody has time to record where the thing went. For decades, historians assumed it had been lost in the chaos of the evacuation or quietly broken down for parts when it became mechanically irreparable. In 2006, a Russian military historian named Yuri Pasholok, conducting archival research into early T-34 production records, found a document suggesting the original prototype had been transferred to a storage facility near Nizhny Tagil in late 1943 and placed in covered storage as a historical artifact. The document was a single line in an inventory list. No follow-up documentation confirmed whether the transfer actually occurred or whether the vehicle survived storage. The trail ends there. Somewhere possibly the specific tank that Koshkin drove through a Russian winter to save his idea is sitting in a storage building unidentified, its angled glacis plate still carrying the geometry that changed everything. The history of the machine that defined the Eastern Front may still be sitting in a warehouse waiting to be found. From a candy factory in Yaroslavl to the glacis plate of every main battle tank currently serving in every military on Earth. From 4 rejected proposals to 84,000 vehicles. From a winter drive that destroyed a man's lungs to a geometric principle that has protected soldiers for 80 years and continues to protect them now in vehicles fighting in conflicts that Koshkin could not have imagined on battlefields he never saw, against weapons that did not exist when he drew the first angled line on his drafting table. Mikhail Koshkin proved that the most dangerous thing a correct idea can do is arrive before the institution is ready for it, and that the only way to overcome that danger is to refuse to stop arriving. His tank saved the Soviet Union. His persistence saved his tank. And the geometry he carved into 45 millimeters of sloped steel saved more lives than any military honor committee ever found the right paperwork to count. If this story stayed with you, leave a comment with the name of another unrecognized inventor or engineer whose idea changed history. There are hundreds of them buried in the archives of every war ever fought, and most of them have never had a video made about them. Subscribe, and we will find them. The man who measured sugar changed the shape of war, and the shape he chose is still keeping people alive today.